function r of t equals 1.5t, where t is measured in minutes. So this is composition of functions.
Okay.
All right, so if it has been 60 minutes since the accident started, was the area of the oil slick. So we're going to do this in pieces. We're going to first figure out the radius as a function of time, which is 1.5t. R of 60 is 1.5 times 60, which is 90. Is that okay?
Yeah.
Okay. And then the area as a function of r is pi r squared. So the radius is now 90. So it's a of 90 is pi times 90 squared, which is 8100 pi, like that.
Okay.
And so that's your answer. Now the units here is in feet. So we'll say feet squared. Now you have to round to 2 decimal places, which I guess means you need to actually multiply 8100 times pi and then round to 2 decimal places.
Okay.
So let me know what you come up with on that.
Wait, sorry, which part am I doing?
You got to put this in your calculator. 8100 times pi.
Oh, gotcha. Okay. 25,434.
Say that again.
25,434.
Yes, sorry, I forgot you're maybe not in a great place. So 2544, 6.90. Yeah, and so that's feet squared. Okay, so that's everything for this one. Let's take a look at the next question here. Part B. Yeah, so here we go. This one you're gonna have to actually I guess let me know if you have any questions about what to submit, but basically all of this would be good to have in there.
Okay.
So now it says to find the function a bubble r of t, a of r of t, like that. Okay, so that means it's you've got the two functions. You've got r of t. R of t is the 1.5t, and then you're putting that in for r, like that. So like a of r is pi r squared. So you're putting that 1.5t in for r. So we have to square this. It's 2.25 t squared, 2.25 pi t squared, like that. And that's your a of r of t, like they're asking for. It's this right here. But you wanna throw some steps here in for that. Let me know when you get all this down so we can move on to part C.
We move the next one.
So part C is basically asking you to back solve this. They're saying if the output is 20,000 and you want to solve for T, how do you do that? Well, you set the area equal to 20,000 and you solve this equation by undoing stuff. So you undo the 2.25 pi by dividing both sides by 2.25 pi. So T squared equals 20,000 divided by 2.25 pi. Take a square root of both sides. T equals the square root of that. Go ahead and grab a calculator and see what you come up with, please, on that. You have an answer for me? Julia, are you still there? It says you're muted. I don't know if you know that or not.
Oh, yeah. My answer is 167.06.
Okay, so depending on what your calculator using, make sure you put that in parentheses. Should be 53.2 minutes. Is what I'm seeing. So maybe just double check that calculation. Let me know when you're ready for us to move to 2.1. Really, are you able to hear me connect with me on this call? Because one of the things I can do here is I can just work through the problems, keep the recording going, and then obviously send it, send you the notes and then the recording later on. It seems like maybe you're not able to hear me or me right now. So I'm just going to keep going here with this. I think that might be the best way to proceed is for me to just continue working on these and don't worry about the issue here. So next problem here is to look at some data, and we only need a couple of pieces of the data to answer this question. So we're supposed to put the high temperature as a function of day. So what this looks like is well, it's really y equals mx plus b. So we need the slope. The slope is 1 because it's going up by 1 each day. But we want to use different variables. We want to say h of t equals 1t plus b. Now to find b, you need to use one of these ordered pairs. I'll use the first one, 95 equals 1 times 1 plus b. And so we end up getting that b equals 94, plugging that back in. And so just to be clear here, this is the line that you want to, or you want to show all this work, but this is the line there for that. All right, so part B, should be home in Tucson. I wonder if I'm missing some information here. Oh, there is more. There is more. Okay. So for part B, I'm going to grab a snip of this. So the cost to heat a home, this is for part B now, it's given by this function, and you need H. So you can't do it without the H function, which you do have. So let's take a look here. So we've got basically we're trying to find C of H of T, which means to take this function right here and plug it in for H. So that's 0.07 times 1t plus 94 plus 0.42. And then you do want to multiply in here. So it's 0.07t plus, got to grab a calculator for that next part, which is 94 times 0.07, which is 6.58, plus the 0.42 equals 0.07t plus 7, C of H of T, like that. Okay. All right, so that takes care of part B. See if there's a part C. There is a part C. Click one ordered pair on the graph of the new function part B and explain what it tells you in the given context of the equation. Okay, so to do part C, snip in part C, basically we have to give it a t value. Okay, so we might as well use like a day. Let's pick a nice one. Let's pick a day 10. Let's say t equals 10, which is day 10. Okay, and we have to put that in here. So it's C of, and this really ends up being C of t, since it's just a function of t. C of 10 equals 0.07 times 10 plus 7, which is 7.7, like that. And so that is the cost. That is the cost to heat a home. So it's the cost in dollars, ends up being dollars there. Cost to heat a home. Cool. Cost to cool. It's summer. All right. So I think that takes care of question 2. So we'll go to question 3. All right, so question 3 is some sort of a graph here. Some sort of a graph here. All right, so let's see if we can get the question here. Part A, draw a detailed graph of the inverse function. Make sure to label all axes, scales, etc. Okay, so to do part 3, you're essentially switching the axes and the points. So on the y-axis will be the quantity sold in thousands. So you just sort of flip here, 10, 20, 30, 40, 50. Basically, you're everything is switched. And then on the other one is the price per repair. Okay. And so what you do is you flip all these ordered pairs. 0.50 becomes 10, 20, 30, 40. You might want to make it nicer than me here. So 0.50, that first ordered pairs goes to 50, 0, which is over here. And then this next ordered pair, which is 30, 40, goes to 40, 30. And then this last one here, 40, 20, goes to 20, 40. So that becomes up here 20, 40 like that. You can see you get kind of it should look kind of similar in some ways. All right, so that's part A. Part B. Part B. So to do this, to do the domain and range of the inverse function, we need the domain of the original. So the domain of the original is bracket 0, 40. And the range of the original is 20, 50. So if you need more explanation, the domain is the x values, the range is the y value. So what happens here is that the range of the original becomes the domain of the inverse function 20 to 50, and that's confirmed by the graph. See how the x values go from 20 to 50? The range of this is the domain of the original 0 to 40. So if we look at the range of the inverse function, notice it starts at 0 and goes up to 40 like that. So there you have it on that one. All right, so I'm just going back to the emails to get the other questions here. Let me go scroll all the way down. Okay, part C. On this, there's no more explanation needed than that. So part C, find the value f inverse of 30. So this means going to the inverse graph, and x is 30 on the inverse graph. Okay, so what that means is go right here to 30, go up and kind of estimate where it is. Looks like it's about 35. So you might say that it f inverse of 30 equals 35. So here's what's going on with that. That means that when the price per repair, so you have to kind of type this out, so I might as well type it for you. When the price per repair is $30, that's where we go find the other units here. The quantity sold in thousands is so we would say 35,000 units are sold. And the order matters, so it has to be in this order, and that's your explanation. All right, so let's go on to number 4. All right, the cost in dollars for manufacturer produce X professional baseball gloves is given by this function here. Find X inverse of 10,000. So we got to find the inverse of this function. To do that, there's a recipe, and then we run, or we could do it graphically, but we might as well do it. By hand. That might actually be part B. Yeah, so we're actually going to do part B first and then go back and do part A. It'll make more sense, I suppose, because I think you can do part A with a graph, for example. So let's do this. Find the equation of the inverse. So what you do here is you switch X. You first write out the original equation, and then you switch X and Y. So X equals 1675 plus 55.5Y, like that. And then you subtract 1675, X minus 1675 plus 55.5Y, equals, which is divided by 55.5 divided by 55.5. So Y equals X minus 1675 over 55.5, like that. Okay, so that is your inverse function. That's X inverse is this. Okay, so that's your part B. That's your part B answer. Now you got to explain what it means in the context of the given problem. That's probably the most difficult part. Is got to go back and find it. So it's basically asking you to we have to use the units. So the original units, we have to switch them basically. So it's the um, the number of baseball gloves produced when the cost is X dollars. Okay, so now we can go back to part A and actually find, we can actually find that value from the equation. So to do that, so now we're going back to A. All right, so you got part A is that you're going to put 10,000 into this equation here. So 10,000 minus 1675 over 55.5. And let's go to the calculator on that. That's 100 and 150. All right, so we did part B. Let's look at part C. If there is a part C, let me look. 4.2. There's a part C. All right. So again, it says to pick says pick one ordered pair. So we kind of have this already from part B. It's that 10,000, comma 150, like that. And so what that means is, and we kind of already wrote this here, so we'll just go back and grab this language. It says that when 10,000 baseball gloves are produced, the cost is $150 per glove. I don't know, maybe that's reasonable. Not really sure. All right, so now we're on to question 5, which has 4 parts. See if we can knock that out here real quick. Looking for the beginning of question 5. All right, here we go. All right, so the Tucson wants to clean up a polluted lake to remove P% of the pollution from the lake. The cost in dollars to C will be COP. P plus $40,000, 100 minus P. So this is, by the way, this is probably a test question. I've seen this before from students, and it really does feel like it. So the input is always the X. The input is the X value, which in this case is the P, which is the percent of pollution. And then the output is C of P. That's really the Y, and that is the cost in dollars. Okay, so that's everything for part A. For part B, you'll find part B. It's to determine the inverse function. All right, so the inverse function, kind of like always, we've got to go switch the variables and solve. This one has a fair amount of work required to do that. I'm just trying to grab a snip of the actual equation. All right, so the inverse function here is you're switching. So one way to do it is to, and I guess I would use Y and X, even though it has different variables in here, just because it'll be more consistent with what you've been doing in the so you switch X and Y. X equals Y plus 40, 1, 2, 3, 100 minus Y. And so now we're solving for y. Okay, so to do that, you multiply both sides by 100 minus y. So on the left here, it's 100 minus y times x equals y plus 40,000. Then you distribute in here. So 100x minus xy equals y plus 40,000. And then you start moving things around here. So I'm going to add xy to both sides. I'm going to subtract 40,000 from both sides. And I'm just going to switch. So I'm going to put this stuff on left. So it's y plus xy equals 100x minus 40,000, like that. And then y is 1 plus x, 100x minus 40,000, and you divide by 1 plus x, like that. So now it's good to go back though and use the original variables. So remember, x is really p and y is really c of p. This is really 100p minus 40,000 times 1 plus p, like that. And that is your inverse. So you might want to say that there, but that's your inverse function. So that's part B. Part C is to pick one ordered pair and explain what it means in the context of the problem. So we should pick some numbers that make sense here. Let's let p equal 49. The reason I'm choosing that is because then the bottom is 50. That looks pretty nice. So it's 100 times 49 minus 40,000 over 1 plus 49. So let's take a look here. So that did not work. 50%. Did I make a mistake somewhere solving for the inverse? Let me go ahead and check my inverse here. E might be, I don't understand. So there is an issue here, which I'm not figuring out. E plus 40,000. Let me go check with another tool that I use to see if I can confirm what's going on here. This looks right. So I'm not sure. Anyway, I guess put a number in here and then explain what it means in the context of this. So result I got there was minus 702. Doesn't make sense. Let me go back and graph the original. Really struggling. I don't know why this isn't working. Well, I'm actually going to go back to the original rather than do what I've been doing here. So forget about all this. The original, one of the points in the original is 0, 400. So that becomes 400 comma 0, which means that it costs $400 to clean up 0% of the waste. I think is a reasonable thing for you to type in here. All right, so that's maybe I'm off here. Maybe that isn't 5.3. Sorry, no, this is all wrong. I'm doing the wrong thing here. Ignore all this. All right, so what is the input and output? So this is where you switch your answers from part A. So the input was originally the percent of pollution. So the output is the percent of pollution P. And the input is the cost in dollars. All right, and then that is sorry, all these pictures came in out of order. Part C, we got part C down, part D. All right, so here we go. So now to do this, to the last one, we're putting in 8,109 in for P. Let's try that here. So end up getting 95. So what that means is that 95% pollution is eliminated, which is a good thing, I would assume. And that is everything. All right, so we're gonna go ahead and stop here for today.